I heard a lot of complaining.
I don't know what I did to get negative 237.
This crap. I call anarchy.
How do you get off by one number?
You go too fast. The answer to this one is 41.
I'm just not doing this.
Yeah, I think that's what.
The winning number today is 5.
It's 7.
4 here, 2 with homework, that is 50%. Now this first one, the tricky part to this one is inside here the brackets, that minus sign changes the sign of everything inside of it, but the shortcut to the problem is, see this minus sign outside the bracket. It changes the sign of everything back, except this 7 becomes negative, as you can see there. So all of this could be copied, and don't change the signs because you have a double, what amounts to a double negative in those spots. Well, either way, once you work it all out and simplify it, you should get 9x squared minus 6x plus 2y. Answer A. Any questions about that problem? Alright, on the second one, how many integers are in the solution set of the absolute value of 2x minus 6 and less than 3? Well, if you put a 4 in, you get an 8. You get 8 minus 6. Absolute value works out. If you put a 3 in, you get 6 minus 6. Put a 2 in, it's a negative 4. Actually, 2 does not work. That one got by me. No, wait a minute, it does work. If you put a 2 in, it becomes 4. Why did I write 2? So you get a negative 2 back. The absolute value is 2, so that works out. And then if you put a 1 in, you come back with 2 minus 6. That's a negative 4, so it doesn't work. And any lower you go, it doesn't work. Any higher than 4 doesn't work. So you're just going to have these 3 numbers, so you have 3 in the choices. Alright, the third one. Oh, this is a fun one. Some of these problems you can actually start working them out, and then you get to a point where you realize that the answer is either expressed differently than what you have and it's the same thing, or you're completely off. In this case, I came down to something that was going in the right direction mathematically, but it doesn't fit what is in the answers. So what I did is I flipped the bottom fraction and multiplied the top fraction by it because of the division. And when you do that, you can multiply across the top and the bottom to come up with this. What I did is I went in this direction by factoring out 2b. If you do that, you're left with this, and then this stays the same. But that's not the direction the answers want you to go in. You only factor out a b to come up with 2b minus 4 over a squared b squared, and then factor out a b from the top and the bottom, and you're left with this one. Neat, isn't it? Here's another one with crazy looking fractions. What I did is on the top find a common denominator and multiply the tops accordingly. Same thing for the bottom. Find a common denominator, multiply the tops accordingly. And then combine them. You have y minus x for that top. And down here it'll be y squared minus x squared. You have to flip this and multiply by the top fraction. And when you do that, before you even multiply straight across, notice that this cancels into that, leaving you with xy on top. And y squared minus x squared is a difference of 2 squares. Don't forget the rule. If you have a plus b, a minus b, that is a squared minus b squared. This is a difference of 2 squares, so you can break that up as y plus x and then y minus x, and notice that this cancels with that one. So you're left with this xy over y plus x, which is choice F. The solution set of 7 over x squared plus 8x plus 23 is 1. If the answer is 1 and 7 is on top, what must this entire denominator be equal to? 7, yeah. So when you do that, you put the set it equal to 7 and then move it over to this side. It becomes minus 7. So you end up with a 16. And this is a perfect square. It's x plus 4x minus 4. But when you try positive 4 in there, it doesn't work out to be a 7. When you try negative 4, it does work out to be a 7. So the only choice you have is C, negative 4. Alright, number 6. If a over b equals 4, then what is a squared minus 16b squared? Well, to get a 4, what I did was choose the lowest possible example I could find that would be a over b would give me a 4. And you think about 16 over 4, 24 over 6, those would all give you 4, but the lowest possible example is 4 over 1. That's what I chose. So that would be 16 minus, if you put a 1 in for b, you still get 16. So it comes out to be 0, h. And this problem is similar, but if x over y equals 2 over 5, then x is 2 and y is 5. You have no other choice. So when you dump it in there, you'll have a 4, x is 2, so when you square it, you get 4. Y is 5, square it to get 25. 100 minus 100 is 0. So the answer is C. 8. This is an ugly looking one, but the only thing you have to remember is this. Make sure that becomes c to the 4th, b to the 4th on the bottom. And your b to the 6th and b to the 4th make a b to the 10th down there as well. And from there it's just factoring out. 3 over 11. And then you have b to the 3rd over b to the 10th. That's where the b to the 7th comes from. And c to the 4th is by itself. So your only choice is this one. How did you like this one? This is a neat looking problem. We need to go through property of logs, and I'll write that one down right off the bat.
That doesn't even look, I don't even know what's going on.
Well, I'll run through and give you the simplest explanation I possibly can. I'll zoom in here. Here's the original problem up here. And what you have to remember, I mean, if you know it, but if you don't, you have to learn it, are the property of logs. And anytime you have this constant e, which is 2.71 approximately, you have to use a log with a base e to simplify it. I know this looks like Greek now, but once we go through the property of logs, you'll be able to understand it. But what I did to solve for t is, first, I divided both sides by e over r. So it gets this expression by itself. So you'll notice down here, where did I start that at? Right there. Divided by e over r. So when you flip this and multiply it, you end up with IR over e. Just division rule. And then on this side over here, it stays just this. You have this 1. Get rid of this 1 and move it over to the left side. So I did that up here. There it is. So you're left with this. Now here's where the property of logs come in. If you have the constant e, really what takes the place or allows you to get rid of that is this, log natural. But you notice in your choices there is no log natural, so you have to use log base e. So what happens is when you take the log base e of both sides of this, and that's what we're doing here, of both sides, log base e of this quantity, log base e of this quantity. This allows you to get the exponent by itself now, because log base e of e to some power is simply that power, and this cancels out. So notice we're just left with the exponent of negative RT over L. And then from there, you have to get t by itself, so you'd multiply both sides by L over R, or a negative L over R. So notice I have that there, and then I still have this inside. I stopped at this point because the closest answer to that point, which I happened to notice I was running out of room, is this one here. See, they have a negative LR, or L over R out front on that. I can't even hardly see it because it's so small. Let me zoom in a second. There we go. They have the negative L over R, but inside they have it reversed, 1 minus RI over E. That's the only difference. But the other choices in there wouldn't make any sense for what we're doing. Alright, the last problem. 2 to the 6 minus 8 power equals 16. What is x? To solve an exponential equation like this, you have to take the log of both sides. So notice I did log here, log there. The property of log says that when you have the log of an exponent here, like this, 2 to some power, it allows you to move that power to the left of the log. So once we do that, we move it out to here. We divide both sides by log 2. So we're left with this, equal to log 16 over log 2. Move the 8 over, make it plus, and then divide by 6. The x is by itself, and when you type this into the calculator, log 6 over log 2, and then plus 8, and then divide that answer by 6, you come out with an answer of 2. A log has a base. It's a subscript base there. You take the log of something, let's call it x, and then you have it's all equal to the exponent. So you have to change your way of thinking. You're accustomed to seeing this. We'll write it here at the bottom. What if I had 3 squared equals 9? You're accustomed to seeing 3 squared equals 9. And you know that 3 is the base, and 2 is the exponent, and 9 is the result. Now you have to change your thinking. In this problem here, 3 is the base. So when you go to write it in log form, you put subscript 3, the answer next, and the exponent is what it's all equal to. So if I gave you a problem that looked like this, let's say I said log base 4 of 16, what you're looking at there is a question. What exponent do I raise 4 to get to 16? It'd be what? The second power, right? So this equals 2. What would it be if I had log base 3 of 27? Yeah, it'd be an exponent of 3. 3 to the third power. What if I had log base 5 of 625? What would be the exponent?
5.
Let's see, squared is 25, to the third is 125, to the fourth is 625, so it would be 4. Close. Do you guys understand the pattern here? Okay, so now when you see something like this, you don't have to be intimidated. Log base 2 of 32 plus log base 6 of 36. Evaluate each part of it. What exponent do I raise 2 to get 32?
4.
Not 4.
5.
5, yes. And what exponent goes on the 6 to make 36? So the answer to this is what? 7, yeah. So that once you figure out this pattern, you don't have to be so intimidated anymore. Now before we get into some more properties, I'll show you a way that you can solve exponential problems. Let's say we had 4 to the x power equals 256. The way you solve that, now with this one you might be able to do it in your head, but on a calculator, in case you get some where you don't know the powers as they progress up, what you do is you take the log of both sides. And a property of logarithm says that log of 4 to some power, that power can go out to the left of the log. So now to solve for x, you divide both sides by log 4. Now in your calculator, type in log 256 and make sure you put a parenthesis around the right side of it. And then hit divide log 4 and hit enter. What do you get back? 4. Yeah, so that's the missing exponent. The answer to this problem here is 4. What if we had 5 to some power x plus 14 equals 139? Start with your simple rules of solving an equation. Isolate the x, move the constant to the other side, change the operation. Ooh, I lowered my x a little bit. X should be there. There we go. Do you need to do the logs to figure this one out? 5 to what power is 125? What is it?
3.
Yeah, it's 3. But if you wanted to figure it out, you would do log of 5 to the x power equals log of 125. And since this is an ACT class, I'm trying to prep you guys to be quick. So whenever you see something like this, instantly go to the calculator and do log 125 divided by log 5. You've got the answer. Simple as that. Alright, so here's another thing we can do. Let's say you have log of 3x. That's your problem. All you have to do is simplify it or expand it. And in this case it would be expand. A property of logs says that when you have the log of a product, and this is a product, 3 times x, you can write it as log of 3 plus log x. Log 3 plus log x. At the same time, if you have the log of a product, such as x over 7, you can write that as log x minus log 7. This. If you have a log of something and there's no base written, the base is 10. If there's a base written, then it could be anything. 2, 3, it could be 100. But the log is base 10 if there is no number written in the base spot. This is a natural logarithm. And the main thing you want to remember with this on the ACT test is the natural logs have a base of e. E is approximately 2.71. So whenever you come up with a situation like this, log natural e, anytime you have log natural e, you can cancel that out and put a 1. The answer is 1, and here's why. The base of log natural is e. So the base of log natural base e of e, what exponent would I raise e to get back to e? If I had 3, could you answer this question? If I had 3 to the x power equals 3, what's the exponent? 1. So it's no different than this. E to the x power equals e, what's the exponent? 1. So that's why you can cancel this out anytime it shows up in a problem. That's where a lot of people get stuck. We start with 2x, 2 to the x power that is, equals 81. minus 17, that'll be a 64 on the right. You need the log of both sides. That's 64, not 2x. Why did I do that? Okay. And then a property of logs is that you can move this x out to the left. And when you do that, log 64 divided by log 2 gives you an answer of 6. Remember, to simplify this in here, you're thinking about 2 to some power equals 32. So you know 2 squared is 4, to the third power is 8, to the fourth power is 16, and to the fifth power is 32. So it's a 5 inside those parentheses. 2 to the fifth power is 32. And then over here, 7 to what power is 49? Second. So 15 plus 8 is 23.